All right, here we got the notes for section 7.4, two dependent samples if you have matched pairs. So use the difference from two dependent samples to test a claim about the mean of the populations of all those differences. Use the differences from two dependent samples to discuss the confidence interval. So notations, D, individual differences between two values in a single matched pair. Mu D, the mean value of the differences D for the population of all the matched pairs. D bar, the mean value of the differences D for the paired sample values. SD, standard deviation of all the differences for this paired sample data. And N, the number of pairs of data. All right, so requirements, they're dependent, so you have matched pairs. Samples are simple random. And either both you have large numbers, there's 30 pairs or more, or you have a population that is approximated normally. So once again, we're using the T statistic. So D bar is the mean value of all the differences. Mu D is the mean value of the differences. So we're going to probably assume that this is 0 because we're going to assume that the populations have the same differences. And then here's our lovely confidence interval formula. Okay, so for example 1 here, just example 1 and 2. Use the data in the table below with the 0.5, so there's our alpha. To test the claim but for a population of heights of presidents and their main opponents, the differences have a mean greater than 0 centimeters, so presidents tend to be taller than their opponents. So for H0, we are going to assume that, where's my notation sheet? We're going to assume that D is equal to 0, and for H1, meaning that they are the same. Let's see here, and presidents, we'll say that D is greater than 0. Because, let's see here, right. No, sorry, not D. Mu D. Mu D 0, mu D is greater than 0, I think. So the average difference, so on average, presidents are taller. Okay, so let's do some math here. So our formula, so let's see, what do we need here? We have the D values already, so we don't need to list those. Mu D, we're going to assume is 0, so D bar, we need D bar. That's the average of all of these differences. So that's 19 plus negative 12 plus 8 plus 0 plus 1. So that is, divided by 1, 2, 3, 4, 5. So D bar is 3.2. Let's see here. SD. So let me go to stats here. 19, actually, we're going to let my calculator handle this. 19, negative 12, 8, 0, 1. Calculate one variable. So S is 11.4. And N is equal to 5. So our T value is equal to D bar 3.2 minus 0. So we're going to assume it's 0 over SD. So that's 11.4 divided by root 5. So let's do some math. So fraction 3.2 over 11.4 over root 5. And that comes out to be, T is equal to 0.627. Okay, so then we got a greater than test. So our rejection region is up at the top. So our score is 0.627 using that alpha. And degrees of freedom would be 4. Our critical value is 2.132. Our test statistic is somewhere in here. So we fail to reject H0. So we cannot say that there is a difference between the heights of the presidents and the height of their main opponents. So even though like this person is much taller, this person is much shorter. So there you go. All right, 90% confidence interval. So our formula for that is T alpha over 2, SD over root N. So our 2132 is that value. So let's see here, 2.132, SD was 11.4 over root n, so 2.132 times 11.4 divided by the square root of 5 gives us an error of 10.87. So let's see here. So it's d bar minus e less than mu d less than d bar plus e is our formula. So d bar was 3.2, so 3.2 minus 10.87. So negative 6.7 is less than mu d is less than 3.2, whoops, plus 10.87. So that's 14.07. So since this range includes 0, we cannot say that there is a difference between the present and their opponent. So present could be shorter, present could be taller, but includes 0, so that we can't make a state for sure which one is true. That is the end of the section.